looked like an interesting tool.
What is it going to do? The LSI?
You can do LSIO-V and list off the different IO devices, just in like we're doing LSUSB to find the USB devices. So it just gives instead of going searching through directories, it gives us a nice little view, and it prints out the name of the sensor, and it prints out the values that it's providing. Here, hopefully they called it that. Yay. Can I do my little demo? I've got a camera hooked up. So, the thing I played with last night, a couple things. One is, it turns out that MJPEG streamer thing with the filter works really nicely. It built on my Beagle pretty quickly, installed easily. The biggest problem was all the dependencies took up a lot of disk space. But that was because I was building it. I'm hoping that if we just have it packaged, so if we get the new version of MJPEG streamer packaged, it'll be really nice and easy just to use that.
You'll add that to the baseline image?
I'll add mapping with JPEG streamer with the. I asked for Robert data last night. Hopefully he got my message. I don't know if he's on vacation or anything right now, but anyway, we'll get the updated MJPEG streamer with the Python OpenCV filtering, which made this.
We're rocking and rolling.
Which made this really, really easy. Here is this is my new. Well, this filter is already fairly complicated because I integrated my line follower into it, which was actually pretty simple. So I integrated my line follower into it because you basically, I hate the word bait. You take this process, you get image in, and at the end you return image. So you just have to create this Python class with the process function definition of image in, image out, right? And then it's a NumPy array. You work on it with OpenCV, and you return the frame at the end. I even resized the frame because I'm getting in this camera only goes down to 640 by 480. I decimate it to 160 by 120 at the beginning without any filtering. I just do a pure sampling.
So, by the way, you have a JPEG that has the full resolution. It's
not a JPEG.
It's in memory. So
it's in memory.
The information is in memory, not as a file because it's just in memory.
And it's not compressed.
Then you subsample that, and then.
So here's my particular algorithm. So I subsample and copy that.
But then in memory now you have two copies, original.
I have the original and my subsampled copy here.
But the original doesn't take any bandwidth of anything from there on out.
Not from there on out. I dump it.
And if you.
But I had to copy it out because if I don't do .copy, then you're essentially defining this to be a mechanism for index pointing into it, and some of the utilities have difficulty indexing into it this way. So I had to do a copy. So I have to do this one extra memory copy at the beginning, but then I'm dealing with a smaller sample of set of data, right?
When you dump the original, do you have to explicitly dump it, or it just gets overwritten with the next stuff that occupies that memory?
Yeah, it just gets overwritten. I don't believe in. It might be a garbage collection thing, but I'm hoping it's just a directly freed thing. I don't know Python well enough. But it comes in as an argument image, and I do nothing else with it. So I'm thinking it's like in C it would be in the stack, so you definitely just throw it away. But here I don't know in Python where it's globally allocated and how it's free. It should be. It's a passed argument, and I'm doing nothing else with it. I I don't allocate a global for it, right? The only globals I'm using here is I'm doing a frame counter, which I'm not using currently, and I'm my dynamic threshold, right? I keep my thresholding for what's white, and my line follower, keep that between runs. I just dumped the whole thing into a try except, just in case I messed up with any of my function calls. It still doesn't crater the whole JPEG streamer. So worst case, it just takes whatever the latest copy of image was, or latest copy of frame was, and returns frame. And then to run it, I've got this little run camera script, right? There's MJPEG streamer with the input OpenCV. I have to bring it in at 640 by 480 because that's all the lowest this camera will support. Run that filter, which is the thing that allows me to do something in Python. And then provide it my script, MJPEG streamer filter. That's what the MJS is. And then output it right back out to that to the stream. So now, should start up, and I will see on 8090. Start up already. It's 8090, right? There we go. And now, ugly resolution, but we can argue about my algorithm, right? But this is running the OpenCV line follower on the Beaglebone.
Does the white cable look like a line?
Do you have? Oh yeah, white cable. There we go. There we go. Brilliant, right? It's got a big white spot from a shadow right there. Here, stand in the shadow. stand in that white spot.
We need a mat.
Now, my particular algorithm, the way it does is you can see it. If it's further away, it has a narrower field. It would be smarter if I stopped looking like both sides. So if I get to see two lines in the view, I don't get distracted by the other one. But this particular algorithm, I was pursuing a different algorithm, and this particular algorithm I came up the morning of a race. Just before I was trying to do really complicated stuff like doing contours and like actually trying to detect that it's a line, rather than saying, okay, this is something that a little, one of these little strip LED things can figure out. Why is it so hard for me to work out in a fancy camera stream, right? Why is this so hard? Well, stop thinking of it like a camera stream and looking for lines. Just say, what do I do if I was doing things with little light sensors on the bottom of a little rover, right? And I would just, think about where is the hot spot in the line and just turn based on where I see the bright spots. So I'm just doing averaging, and it's just a tremendously simple algorithm. You can see it runs super fast, right? It decimated a lot to help with the speed for sure, but it also just doesn't.
That bad.
It just doesn't need to be that, right? This is plenty of image quality for following a line.
We need you to help us track the ball super fast.
Shouldn't be that hard. I'm sorry, I'm going to do it. No dread. I think that what we're doing with our dashboard, sometimes I just forget about the tools that are available to me. And
so first of all, with the video, this is our best performance tool. To use it, we just need to run the command and then log on to this page, this 192.168.
Well, it's running without you consuming it. So the algorithm's running all the time.
So we plug in our camera, we go here.
We start this and we start the program.
That's what I meant. So.
We can add UDEV roles so that the program automatically start with the camera.
No, it's okay.
But
we just have to run the command that starts the program, which is.
In my example, it's run camera.
These print that MJPEG streamer command.
Yeah.
The MJPEG streamer command is this.
It was like 4 commands. Did you compress it into one?
No, it's just.
It's just really long because you specify all these different plugins that are used within MJPEG streamer, so you have to give.
So are we ready to run that on ours?
You just need this version of MJPEG streamer because this is a newer version of MJPEG streamer that Daniel found last night.
So we need.
Well,
let's put in our
yesterday.
notes the command to download or install that one, right?
Yeah, you don't just get a newer image. We're gonna ship it in the image. Just get a newer image. Maybe it'll be next week, but worst case.
Well, I just want to come back and try out everything from this workshop in not too long, so that we can kind of remember it.
Yeah. So I downloaded the sources. The biggest thing is I had to delete a bunch of stuff off my disk to make it fit. So I would not expect you to go and build MJPEG streamer from sources. That's a little bit of a.
Yeah, we'll download the new image and I'll be trying it right away.
Thank you. Perfect. I think this will make debugging in the classroom tremendously easier because you'll be able to see the live output.
We'll take a 1 month effort into a 10-minute effort.
Yeah. And way easier than trying to run a OpenCV application GUI.
You're well on your way to convincing Danielle that Beaglebone is better than Pine.
Don't respond to that. Come on, Nodria. There we go. So apparently it's a little busy doing its little thing, by the way. I should probably put some sleep commands in there. Yeah, I mean, it's just fully loaded. There's basically, I'm using every free cycle processing, right? If I put a sleep in here, it'll be really nice to the system. It's still reasonably responsive, but right now it's basically chewing up all the extra free time. I didn't leave any extra room as of now. So if I was doing this, if I would, at this point I would say I need to reduce my frame rate or otherwise adjust my algorithm to not consume 100% CPU. The fact that I'm drawing this back on the images in order for display, that's something that I would expect you to only do debug. So I would expect you to try to want to set like some sort of debug flag. And anyway.
I mean, should we do this along with you, or are we missing anything to be able to drag and drop parts on? Watch the demo first.
Watch the demo first. So this is Node-RED, and Node-RED is a tool that's running on the Beagle, where instead of writing your JavaScript code as like code, it's just drag and drop blocks. So you have all of these blocks to pull from. Everything is done as a message with a payload. So there's a message object that's passed in between these different things, and it contains a payload. So, and it's all done in this flow graph style. So I start a message here, and then it goes to this place, and it goes to this place, and this place, and this place. This is how things run. Is when they get a message, they process the message, and they may or may not produce an output, or they may produce an output at any time. Either way, their output goes wherever the other line is connected, and their input comes from wherever the one of the input comes from the left, and output goes to the right. Like we read. So to create a reoccurring event, you can use this inject node, and every 200 milliseconds, I am sending a message where the payload is a timestamp. Doesn't matter what the payload is. I can change this to be nothing, but I happen to be grabbing a timestamp and sending along. I give it a name because that's what shows up on the box. And I'm trying to think if there's anything else interesting about this. I gave it a topic. A topic gets to be interesting